Thank you. Good morning and evening. Now I want to tell you about the University Project Gxiba-1, UPAEP-Mexico. The second Aerospace, the UPAEP design, integrated, and operates, and the second Mexican satellite deployed from the International Space Station. And yet its mission is to photograph Mexico's active volcanoes, above all Popocatépetl. To study how ash is dispersed and to deliver that information to SNII-I. We reach space through the KiboCUBE program run by UNOSA and the Japanese agency JAXA, which allow university in emerging countries to deploy a satellite from the Japanese KiboCUBE. It all started in 2021 when we decided to enter the sixth round of KiboCUBE. It was a multi-stage process through the year: mission proposal, technical review, and team evaluation. In December 2021, the result was announced. UPAEP has been selected as one of the two winners of the KiboCUBE program that meet launching and deploying a one-unit CubeSat from the International Space Station. The official announcement was published in February 2022. Sometime I went to stretch. We did not start from scratch. We built the project plan on the lesson SNII-I left us, our first nanosatellite with NASA. We already knew which document and space agency requires, where a schedule get compromised and which risk to attack first. That experience saved us as month. This is the photo of the team that started Gxiba-1. We kept a strategy that worked very well for us on SNII-I. Every cycle, we bring in first semester students so that when the veterans reach at the end of their degree and graduate, someone is already training to take their place. A 4 years project outlasts a generation of students without handover. The acknowledged lives with every graduation. It all close to 80 students and 12 professors passed through the project. And not only engineers, students from law, design, marketing, and communication also took part, because a satellite needs permits an identity and outreach. The payload is a visible spectrum camera on the one-unit CubeSat, orbiting at 400 kilometers. With it, we aim to photograph active volcanoes, mainly Popocatépetl, to analyze ash dispersion. There is an architecture decisions worth explained. Image processing happens on board. The satellite no need to downlink the full photo. It downlinks the analyzed result and its health status through the Iridium constellation. That gives us near immediate contact without having to wait for the satellite to pass over Puebla. It's also transmit and receive on UHF in the amateur band to our ground station and send periodic messages that any radio amateur worldwide can pick up. The integration was fully carried out of the UPAEP laboratories in Puebla, becoming a technical immersion environment where students took the lead under our supervision. By physically assembling the structure, power system, onboard computer, UHF and Iridium communication, magnetorquers, and the camera, the students gaining empirical space engineering skills. The hand-on learning was speaking using the FlatSat. This functional tabletop replica allowed them to iterate on software, power, management, and protocols, losing the fear of failure before handling the flight model. To this day, this simulation continues to train them as they research every space combat. Furthermore, they internationalize the rigor of technical documentation. Each generation translates its successes and mistakes into written procedure for the next, achieving exceptional maturity and acknowledged transfer. JAXA visit UPAEP. In March 2025, JAXA engineers come to Puebla. We formally introduced the Gxiba-1 team and worked together for several days in the laboratories, reviewing the integration, test procedure, and acceptance documentation, with the flight model handover already on the horizon. For the student, it was a different experience from the video course, asking questions face-to-face, getting correction on the spot, and watching an agency engineer at work. It was also a sign of trust because JAXA does not visit all of its team. The agency itself documents the visit on its website with photos of the work done in our laboratories. Those are images on the slide. Before sending the satellite to the International Space Station, the students learning to engineering demands absolute rigor through the fixture. By inserting the CubeSat into the GSOT container, the student conducted mechanical validation, verifying external dimensions, sliding along rails, activating confinement switches, and the CubeSat center to the mass. They empirically assimilated that working with tolerance and tenths of a millimeters is not negotiable. They internationalize a profound professional responsibility. If a component fails to deploy, their error will affect other missions sharing the launcher. Passing this test means a technical consecration for the young team. They demonstrated that the millimetric precision they had implemented in Puebla laboratories met all the strict standards of the JAXA agency. A student must learn how hardware survivor launch and the harsh condition of space. They absorbed this lesson at UNAM facilities in Mexico. During vibration tests, our team experienced what the satellite feels during a rocket ascent, and analyzing data so nothing comes loose or resonate. Through thermal vacuum trials, they evaluated it across the hot and cold cycles of the space with a deep electronic. Mastering these profiles taught them JAXA strict requirements for payloads passing through the International Space Station. In August 2025, we traveled to Japan with the satellite. It arrived at the Tsukuba Space Center early in the morning, and on August 7, the formal handover ceremony took place, attended by the development team, staff from the Mexican Embassy in Japan, and JAXA personnel. After the incoming inspection, the certificate of acceptance was signed. The piece of paper changed everything. From the signature on, Gxiba-1 was in JAXA's hands to be integrated in the GSOT deployer and fly to a station on HTV-X, Japan's new cargo vehicle, on its main flight. On October 26, 2025, Gxiba-1 lifted off from Tanegashima aboard the H3 rocket inside HTV-X1 and reached the International Space Station on October 30. It waited its turn a few months. On February 3, 2026, at around 2:30 in the morning Mexico time, the Kibo module's robotic arm extended this so number 35 and released Gxiba-1 together with the Italian satellite Cora. The command was sent from the Tsukuba Space Center with Mexico's ambassador to Japan, Melba Priya, person along with part of the team. In Puebla, we followed it live in a room that was full at that hour. For years of work came down a few seconds of video. The satellite drifted away from the International Space Station, now in its out orbit. In daily operation, we handle three fronts: the beacon, periodic UHF amateur band messages that include Senapress volcanic alert level. Any radio amateur can receive them, continue the AztecSat-1 experiments. NORAD identification. Here we have a real open item. Since 6 satellites came out the same day, the catalogs got crossed. SACNOT lists us as 67,684 and N2YO as 67,685, shaping with respect to Cora. We're working with the SpaceTrack and our observation to confirm the identity and are reaching out to the Coral team to correlate telemetry. And Iridium, the short message channel through which we receive the satellite health and the processing result without waiting for passes over Puebla. Where are we and where are we heading? Today, our priority is to consolidate two-way communication, straining the uplink and the downlink, validating every adjustment on the flat side before applying in the orbit. The mission is planning for about 12 months. At the end, the satellite re-enters and burns up in the atmosphere. It has no proportional lift to space debris. Looking ahead, Gxiba-1 is the proof of concept for something bigger, the MEMA program, monitoring and exploration of active volcanoes, which combines satellites, stratospheric balloons, drones, and rovers. The next satellite, Gxiba-2, will carry a hyperspectral camera capable of identifying volcanoes gases, not just ash. And the federal government invited us to collaborate with UNAM, IPN, and CICESE on an Earth observation satellite constellation. The experience is not stopped with Gxiba-1. We have already started KUSAT, and we are starting where you should start, mission definition. Before building anything, we define what we want to satellite to do and what is scientific and technological contribution will be. The difference from our previous project lies in the starting point. Today, we have to complete cycles of experience, AztecSat-1 with NASA and Gxiba-1 with JAXA, documented procedures and operating ground station, and professor and alumni who have lived through every state of a mission. KUSAT will also serve as the training project for the next generation of students, thus taking the baton from those operating Gxiba-1 today. And the bond with Japan does not end with the deployment. One the alliance we are seeking to build is with QTech, the Kyushu Institute of Technology. probably the university with the most experience in the world in the university nanosatellites. The BIRS program came out of there, and has training satellite engineers from dozens of countries. In fact, satellites with QTech participation left Kibo the same days as ours. The partnership we are proposing has three lines: student mobility, so that our students stay in Japan; John's satellite project, in which each institution contributes to system testing and ground station; and research and graduate studies, opening the door for UPAEP alumni to study space engineers there. Is the natural continuation of the break opened by KiboCUBE. Sorry. Sorry. I want to close by giving thank yous to JAXA for the technical guidance over these years, for the visit to Puebla, for hosting us at Cuba, and for flawless launch and deployment. To NOSA, because KiboCUBE delivers on its promise that the university in emerging countries develop real space capabilities, not simulate ones. I would especially like to thank our colleagues and friends at the Universidad del Valle de Guatemala, who shared with us the lesson they learned with KiboCUBE. Thanks also to UNAM for the environmental testing, to the Mexican Space Agency, to the Mexican Embassy in Japan, and to CENEPRED. And above all, to the student and professor who sustained in this project for 4 years. Our rector, Dr. Emilio Baños, put it well after deployment. This challenge gives a student a knowledge and a skill that will be part of their future, whether in industry or in academia. Gxiba-1 passes over us every 90 minutes. It is still up there, working. Thank you very much for your attention.